This is Unit 6, Quads and Polygons, Lesson 6.3, Rectangles, Rhombis, and Squares. Make note of where you are watching this video and the date and time. Don't forget a parent guardian signature sign-off. If you are multitasking at this moment and trying to watch this video as well as track your Facebook or instant messaging or something of that nature, please turn all other distractions off. Focus solely on this assignment. So last class, we talked about the properties of parallelograms. It says the diagram below is a parallelogram. Find the measures of all possible angles and solve for any variables. Now, the minute you notice something is a parallelogram, you want to immediately think of OCD. And with that note, instantly think of that acronym and then work it out on the diagram what that means. For example, the first one is opposite sides are parallel. So you should mark opposite sides parallel. In fact, get in the habit of stretching them out. So they're parallel going both directions. The next one is the fact that opposite sides are congruent. So hatch mark opposite sides. Third thing is opposite angles are congruent. So angles that are across from each other are congruent. C is consecutive angles are supplementary. So I'm going to put a bracket here. Angles that are next to each other, supplementary, means they add up to 180. And last but not least, the diagonals bisect each other. We only have one diagonal here. We don't need the other. So with this, let's find all possible items. And the first one is this. Opposite sides are equal. So I know this length of 4x is equal to this length, which is 16. So there's one variable there we figured out was the fact that x equals 4. Opposite angles being equal, if this is 98, back here this is 98. The fact that triangles add up to, consecutive angles are supplementary means this angle and this angle add up to 180. That makes this 102 because 180 minus 98, that's not 102, just a second. It's 82. With that understanding, you also know that opposite sides are parallel, so we have armpits of the Z going on here, which means this is 39. Which gives us the ability to find this angle right here by doing 82 minus 39. We get 43. Armpits of the Z work this way as well. And now you found all possible angles and all variables using OCD. So today we're going to talk about the family of parallelograms, So you're going to be talking about a parallelogram, a rectangle, a rhombus, a square. Watch out for the word perpendicular and quadrilateral. So here's kind of a trick question. This is famous on SATs. Is a rectangle a parallelogram, a rhombus a parallelogram, and a square a parallelogram? The answer to all of these is yes. A rectangle, a rhombus, a square are all types of parallelograms, just like a Toyota, a Saturn, and a Honda are types of cars. So we've talked about parallelograms. Let's recap what we know about parallelograms. One, we have 4 sides and we have angles which sum 360. Now that's true of all quadrilaterals, not just parallelograms. We also learned that opposite sides are parallel, going both ways. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary, which means angles that are next to each other add up to 180. And the diagonals cut each other in half. They go through each other's midpoints. Now, these are the OCD qualities of a parallelogram. Now, we have two types of parallelograms, which are descendants of parallelograms with specific qualities. One of them is a rectangle. Imagine if I took a parallelogram. So imagine this parallelogram, and we just shoved it a little back this way. We tilted it so that we made all four angles right angles. So we take a parallelogram, but we shove the corners back so that all four corners make a right angle. Imagine if we were to make a right angle there, what would we get? We'd get a rectangle. Therefore, a rectangle is simply a parallelogram that has four right angles. A rectangle is a parallelogram that has four right angles. Now imagine if you were to take a parallelogram and you'd shrink these sides up to make them all equal. What would you end up with? You'd end up with a rhombus. Therefore, a rhombus is a parallelogram with all congruent, it should read sides, with four congruent sides. So let's recap this. If you have a parallelogram with four right angles, you have a rectangle. If you have a parallelogram with four equal sides, you have a rhombus. So you start with the humble parallelogram. And if you make four right angles, you have a rectangle. And if you make four equal sides, you have a rhombus. So both a rhombus and a rectangle are parallelograms. Since they both are parallelograms, they have all the OCD qualities, just like you inherit qualities from your parents genetically. So a rectangle has all the OCD qualities, so does a rhombus. Now, what are things that make a rectangle unique? One is this length of this diagonal going this way, and the length of this diagonal going that way are equal. So we have congruent diagonal lengths. And of course, you have four right angle corners, four right angle corners. Now, what makes a rhombus unique, besides the 4 equal sides, is that the diagonals, when you draw them, they actually bisect the corner angles. That doesn't happen in any old parallelogram or any old rectangle. So it actually cuts these corners in half. So a rhombus not only do the diagonals bisect the corners there, but it creates a right angle on the inside. The diagonals bisect the corner angles, and most importantly, the diagonals are perpendicular to each other, which creates lovely right triangles. Behold, you got another right triangle to hunt you. Watch out for those. You're going to be doing stuff with them. So what we have here is we've gone about halfway through parallelogram. We have all the OCD qualities, the descendants of a parallelogram, which are rectangles and rhombi. And then if a rectangle and a rhombus gets married, they have a square. So let's finish that up here. If you have a parallelogram, you make 4 right angles, you have a rectangle. 4 congruent sides, you have a rhombus. Rectangle, rhombus get married. Mom and dad get married and have a kid, and they have a square, which both has right angles and 4 equal sides. So it has both the qualities of mom and dad. The rectangle, a square is a rectangle, and a square is also a rhombus put together. Here's a list of things that you need to watch out for in a rectangle. This is from your quad family tree. A rectangle is going to have 4 sides, angles at some 360. Opposite sides which are parallel, opposite sides which are congruent, opposite angles which are congruent, consecutive angles that are supplementary, diagonals that bisect each other, diagonals that are congruent in length, and 4 right angles. Knowing that, with this given information, we're going to find all possible angles and sides in this lovely diagram. Now notice that was a squeeze suspense, so our goal is to find all possible. Don't get all happy when you solve for a variable. You're barely halfway there. Colors are really helpful for this, so I'm going to just pause for about 20 seconds, and if you can get at least 3 or 4 different colors out, that would be helpful. All right, let's see. Make sure you label very carefully, dot to dot, pencil on your paper. Don't use your eyeballs, use your fingers to trace. E to I. So I put my pencil on E and I trace to I. And I write that down. That is going to be 2x plus 1. And then I have F to H. That's F going to H, the whole thing. And that's going to be 3x plus 10. And then I have this angle here, IFG. You dot to dot, trace and sweep the elbow of that angle, and the elbow is always going to be that middle letter. So I start at I go to F, I go to G, my elbow is right there. The elbow is always the center letter. That's going to be 51 degrees. Our goal is to find everything possible. Well, let's start with what we know. We know it has the OCD qualities, plus we have 4 We have right angles in the corners, and we have diagonal lengths which are congruent in length. So that means if these diagonal E to G is the same length as F to H, which in a rectangle it is, and they bisect, that means all four of these pieces are equal. We also know that we have opposite sides that are parallel, so I can go like this. Parallel sides. So let's deal with the segments first. It's always most important to do a thing equation before you do the algebra. Do not get so involved with the algebra that you forget just to ask yourself, what do you know about the things? So I'd like you to trace the segment EI and trace the segment FH, because that's where we're given algebra. And ask yourself, what's the relationship going on there between those two? I'd like you to write a statement about the relationship of EI and FH. See if your statement's going to match mine. Let's see if we're thinking along the same lines. EI is half the size of FH. Or another way to say it, it takes two EIs, two of the blues, to make one of the greens. It takes two of the blues to make one of the greens. Now, using that as your template, now we can do our algebra. So two EIs, circle plug, chug, FH. Really important you do that template first. Many students would have just made this equal to that because they're just used to making algebra and slamming it together, and you'd be wrong. It's two blues equals one green. With that, we're going to solve for X. As you can see, the algebra is relatively easy here. If we make sure we do our algebra correct to begin with, which 2 times 2, I didn't say that out loud, it is 4, my friends. Hopefully you caught that. Okay, let's try this again. I'm going to minus 3x, I'm going to minus 3x and bring it over this side. I have x plus 2 equals 10. X equals 8. Now, there's a super easy way to test this. We actually just plug it in. EI is going to be 2 times 8 plus 1. And FH is going to be 3 times 8 plus 10. Let's see if they have the correct relationship. 2 times 8 is 16 plus 1, that's 17. 3 times 8 is 24 plus 10, that's 34. Do 2 of these fit in one of those? And the answer is yes. So now we found the actual length here. Just going to erase these and put in the numbers. This is 17, and that's 17. The whole thing's 34. Put 34 in the middle, or put a little baby 17 and 17 on each of these. Now we also want to find all the angles. Now remember, we have right angles in the corners. So right here, if this is 51, so now we're going to focus on the angle and see what we can get with the angle here. This is the 51 that we were given. Because the very first thing, opposite sides are parallel, we can do armpits of a Z, which makes this 51. Now, keep in mind that this is a right angle, so we simply can do 90 minus 51, and that's going to be 39. Because of opposite sides being parallel, we can bring that 39 down here as well. Now let's focus on this triangle. Trace it with me, please. E, I lost track what's in the middle here. I, F, that triangle right there. Trace it, please. Now I'd like you to trace E to I. Now trace F to I. Do it again. E to I, F to I. Notice those hatch marks there? That, my friends, is an isosceles triangle. And if you have two equal sides, we have two equal angles, which means we can bring this 39 here as well, and down here. And that means we can also walk this 51 down here and down here. You think you're done, but you're not, because triangles add up to 180. We can add 39 plus 39. It's going to be 18, carry the 1. That's 78. Take it away from 180, and we get 102. Guess what? That's 102, which means this is 102. Vertical angles. And then because this adds up to 180, this is 98. This is 98. Now, you think you're done. You have truly found all the angles, and you think you found all the sides, but not quite. Because, watch out here, I'd like you to trace E, H, F, please. Do you notice that's a right triangle? Let's pull this out. This length right here we found earlier was 34. This is 51 degrees, and this is 39 degrees. This was E. This is H. This is F. Guess what? We can also find these outside sides using SOHCAHTOA. I'm going to work, it doesn't matter which one you work with, I'm going to work with 59. That's going to make this side the opposite. This side the adjacent. And then, of course, we have the hypo. I'm going to go for the opposite first using sine. So I write sine of theta over 1 equals opposite over hypo. I'm going to go for the adjacent using cosine. So cosine theta over 1 equals adjacent over hypo. I'm going to do my plugins. I have sine of 51 degrees over 1 equals opposite over my hypo, which is 34. Cross multiply. I'm going to end up with the opposite equals 34 times sine of 51 degrees. So I do 51 sine times 34. I'm going to round it to the second decimal place. That's 26.42. You thought you were away from SOHCAHTOA. I warned you that you'd never get away from SOHCAHTOA. Every time you have a right triangle, you could potentially use SOHCAHTOA. Now to get the adjacent, we're going to cross multiply here. It's going to be cosine 51 over 1 equals our adjacent, which we don't know, over our hypo, which is 34. Cross multiply. We have cosine 51 times 34 equals our adjacent. So I do 51 cosine times 34, and I get 21.39, except that rounds up, so it's going to be 21.40. So our adjacent is 21.40. So back to your original rectangle here. This length right here is going to be 26.42. Opposite sides are equal, so this is also 26.42. And the left and right are both going to be 21.40, 21.40. Now, we were able to get all of that information just because, basically, I told you it's a rectangle. So that's why it's important for you to memorize all the qualities about a rectangle, because you could use all of that information to do a squeeze a sponge problem. So that's an example of a rectangle. Now this one is a rhombus. And here are all your qualities from a rhombus. I'd like you to take this information, put it on the rhombus, find all possible angles and sides. I'm going to give you 2 minutes to do this, and then we're going to recap this together. No, I'm going to give you 3 minutes. Okay, let's see how far you got. Now, a rhombus. Keep in mind the qualities of a rhombus. They have all the OCD qualities. There's the OCD qualities right there. That means they are a parallelogram. And then we have the specific qualities that the diagonals are perpendicular and that the diagonals bisect opposite angles. This one is by far the most important, the fact that the diagonals are perpendicular. That should have given you right angles, which basically helps you find everything. Let's start with the simple stuff. We are told that PR is 10. So P to R is 10. Now I'm going to instantly, because I know the diagonals bisect, I'm instantly going to break that down to 5 and 5. And you should have done that as well. And then we're told that QR is 13. So QR is 13. Notice I'm crossing stuff out as I go. TQR, that means Q is going to be our elbow. So we start at T, we go to Q, we go to R, trace and sweep. That is 23 degrees. And from there, our goal is to find everything. Well, let's see what we can do. We know that these diagonals bisect opposite angles. So that's 23, that's 23. We also know, because it's a parallelogram, that opposite angles are equal. So that means this is 23, and that's also 23. We also know, because it's a parallelogram, that consecutive angles, angles that are next to each other, add up to 180. So 23 plus 23 is 46. We take that away from 180. You get 134. So this whole angle is 134. We're going to divide that by 2 because the diagonals bisect. And we get these two angles, which are going to be 67 and 67. And then the angles in the middle, which are absolutely the most important, is that fact that we have right angles here. Okay, so we have found all the angles. The sides is actually easier than you think it is, because if you look very carefully, we have a right triangle. I pull that right triangle out for all to see here. We have a right angle here. So as you bring this triangle out, we have a 13 here and a 5 here, and the only length we don't have is from Q to T. We're just going to call that X. Well, we have a right triangle, and we have two sides, and we need a third side. You heard that? That should jingle something. Two sides, you need a third side, you do to sag. So here we have x squared plus 5 squared equals 13 squared. This is x squared plus 25 equals 169. Wow, how did I do that without a calculator? Because I have memorized my perfect squares through 15, which you should do as well. We're going to minus 25 both sides. X squared equals 144, therefore x is 12. So we just found that this is 12, that's 12. Outside, all four sides are equal, so that's 13, 13, and 13 all the way around. We need to start working on memorizing all the qualities on this page right here. This is called the quad family tree. So start memorizing. So far, we now have that much under our belt. Don't be panicked with the volume that you have to memorize because several of the items are repeated. The OCD qualities are repeated throughout. And then you just add a couple qualities for each of these.